Welcome back to English Podcast Go. I'm Cyrus, and each episode brings you closer to confident English. Let's jump into today's episode.
Okay, let's unpack this. When you look up at the night sky, those countless stars, the source material we're diving into today paints this picture, Our Milky Way, 100 billion stars, like lights in cabins of a giant spaceship. It's a really powerful image, isn't it?
It really is. And it immediately makes you wonder, are we the only passengers on this incredible journey?
Exactly.
And the perspective in this material, it takes that thought a step further.
Yeah.
It suggests that thinking we are somehow unique, the absolute pinnacle of creation, might actually be a bit, arrogant.
Arrogant, yeah.
Especially, and the source kind of has a wry sense of humor here when you consider there's certainly room for improvement right here on our own planet.
A very fair point. So if we're perhaps not the only ones, and maybe not even the most advanced, the big question becomes, how do we actually find out?
Right.
If we're not actively looking for evidence, we might be missing something huge.
Precisely. And this material makes a really strong case that we need to move beyond simply waiting, waiting for someone to call us, like passively hoping for radio signals.
Which we've been doing for a while.
For a long time. The argument is that a more proactive approach is needed. We should be searching for physical objects, actual things that could have originated from interstellar neighbors.
Ah, okay. Like finding a tennis ball in your backyard that clearly came from next door.
Exactly that analogy. It's physical evidence of activity.
Right. It's physical evidence. So our mission in this deep dive is to explore this perspective for the material you shared, unpacking the arguments for this active search, the proposed methods, and looking closely at the potential evidence that's already emerged or is being sought.
And it all stems from a fundamental point about, true scientific inquiry.
Which is about genuine curiosity, right?
Yeah.
Looking for evidence without predetermined notions or letting popularity influence the search. It's not based on the politics of getting the largest number of likes, as the source puts it.
Exactly that. And contrasting that with what the source calls the adults in the room attitude, where people sometimes pretend to know more than we actually know. It advocates for the pure wonder of a curious farm boy, just looking around, being open to whatever it brings to our doorstep, You have to be willing to actually look.
And traditionally, how have we been looking? It's mostly been searching for radio signals, right? For the better part of 70 years?
Yeah, about 70 years, which, as the source puts it with a great analogy, is like staying at home and waiting for a phone call that may never come.
And why might that call never come? What reasons are given?
Well, there are several possibilities raised. Maybe nobody cares that we are lonely, or perhaps other advanced civilizations are, like some predict for us, totally addicted to digital screens.
Living in virtual reality or something.
Right, just existing in virtual realities, no longer bothering with broadcasting signals out into the cosmos. Could be.
Okay, so if just waiting by the phone isn't the most effective strategy, what alternative does this material propose? What's a much better approach?
The suggestion is, instead of just waiting for a signal, let's check if there is any object in our backyard that may have arrived from a neighbor's yard.
So physically searching our local cosmic environment, finding stuff.
Right. Finding that interstellar tennis ball, as it were, could tell us if someone next door is playing the game. And what's striking, really, is that this kind of physical search, it's something we've only really started doing systematically in the last decade or so.
And it's in that recent decade that we've already encountered some things that don't fit neatly into our existing boxes. Let's start with ʻOumuamua. That was a big one.
Ah, yes, ʻOumuamua. Discovered back in 2017 by a telescope in Hawaii. It was the very first object astronomers identified from outside our solar system that just, it looked really weird.
How weird are we talking? What specifically made it stand out?
Well, for starters, it was about the size of a football field as it passed through our neighborhood. Big enough to notice. But its shape seemed extreme as it tumbled every 8 hours or so. The amount of sunlight reflected changed dramatically by a factor of 10.
A factor of 10?
Yeah, which suggests a very elongated or perhaps flat geometry. The source says most likely flat, like a pancake.
Okay, a tumbling cosmic pancake the size of a football field is definitely unusual. Got it.
But then it did something even stranger. It was observed to be pushed away from the sun by some mysterious force.
Pushed, but not like a comet.
Exactly. Without any of the signs you'd expect from a comet, there was no evaporation scene, no tail of dust or gas trailing behind it.
Yeah.
Natural outgassing is usually what gives comets that little extra nudge when they get close to the sun.
So if it wasn't outgassing pushing it, what was? What's the theory?
The source suggests that the reflection of sunlight itself, solar radiation pressure, could provide the push. But, and this is the key part, only if the object was incredibly lightweight and thin, like a sail. That's the comparison used. This is a key piece of evidence pointing away from it being just a typical rock or comet. It strongly suggests it was not produced naturally.
So what could it be then?
Well, the possibilities raised include it being maybe a super thin surface layer shed from something larger, or even, just space trash, like a plastic bag tumbling in the wind.
Space trash.
Yeah.
Or perhaps something designed, engineered. That certainly fits the finding something physical from a neighbor idea. But this wasn't the only strange object mentioned in the material, was it?
No, not at all. The source also highlights an event from a decade ago, a meteor that entered Earth's atmosphere and burned up in 2014.
Right, the one detected by U.S. government satellites. I remember hearing about this.
Exactly that one. It was smaller, maybe about half a meter across, but it generated a fireball with a few percent of the Hiroshima atomic bomb energy as it disintegrated in the atmosphere. Quite powerful for its size.
And the crucial property, the thing that marked it as interstellar.
Its speed. Simple as that. It was moving too fast to be bound to the sun's gravity. That high velocity alone told scientists it had to have come from outside our solar system.
And didn't the U.S. Space Command confirm that later?
Yes, they did. They released a letter confirming its interstellar origin with 99.9999% certainty based purely on its speed, which was faster than 95% of nearby stars relative to the sun.
And this object also had unusual material properties. It wasn't just fast.
Correct. It showed unusual material strength and unusual speed. The source makes an interesting comparison. Now think about our own space probes, like Voyager. If a future Voyager-like meteor, one of our own artifacts, were to collide with a distant planet,
It would look like a meteor.
it would appear as a meteor with exactly these kinds of properties, very high speed and unusual toughness. This 2014 meteor exploded relatively low in the atmosphere near Manus Island in Papua New Guinea, which implies it was tougher than even iron meteorites.
Tougher than iron. That is significant.
It really is. That material strength is a key point.
Now, the material notes that after ʻOumuamua, another interstellar object did show up, a comet, I think, and that one did look pretty normal.
That's right. A later interstellar comet looked much more familiar, like the comets we see from our own Oort cloud, which understandably led some colleagues to argue that perhaps ʻOumuamua and the 2014 meteor were also just natural, albeit weird natural things.
Like rocks of a type that we've never seen before.
Exactly. That was the argument.
But the source uses an analogy to push back on that conclusion, doesn't it?
It does. Saying something like, look, if you see a weird person walking down the street and then later see a normal person, it doesn't suddenly make the weird person normal.
Oh, good point.
The fact that one interstellar object looks familiar doesn't automatically explain away the really unusual characteristics of the others. Each needs to be assessed on its own merits.
Okay. So with these intriguing objects identified, these anomalies, how do you move from sort of theoretical interpretation to actively searching for more and, crucially, for actual physical evidence?
Well, the source acknowledges the U.S. government's reports on unidentified anomalous phenomena, UAPs, the current term for what used to be called UFOs.
Right.
But it makes the important point that the sky is not classified. Scientists don't have to sit around and wait for government agencies whose main job is national security anyway to release data. Scientists can and should build their own instruments and look independently.
And that's where projects like the Galileo Project come in, led out of Harvard.
Yes, exactly.
Yeah.
The Galileo Project's goal is to systematically monitor the sky 24/7 using telescopes and cameras, specifically looking for objects that are not familiar.
So filtering out the normal stuff.
Right. Distinguishing them from known objects like birds, balloons, drones, airplanes, satellites, all the usual suspects. And they're employing machine learning software to help sift through the huge amount of data they're collecting.
Makes sense. What's the latest on that search? Have they found anything yet?
Well, at the time the source material was compiled, they had monitored something like 500,000 objects and haven't found anything unusual yet that fits their strict criteria for an unknown. But the important thing is they keep looking. It's a continuous, systematic effort, which hasn't really been done before in this way by academia.
Okay, so that's the sky survey. But perhaps the most concrete step described, the most direct search for physical evidence, is the Pacific Ocean expedition from June 2023.
Absolutely. That expedition had a very precise target to try and recover actual materials from that 2014 interstellar meteor, the one that burned up near Papua New Guinea.
So they went to the spot where it likely came down.
Pretty much. The search area was calculated based on the Department of Defense data near the explosion point, about 90 kilometers away from Manus Island.
How do you even begin to search for tiny fragments of a burned-up meteor on the ocean floor, like a mile down? That sounds incredibly difficult.
It is. They used a specialized sled, basically a platform with strong magnets attached to both sides. This sled was designed to be towed along the seabed by the ship.
The Silver Star, right?
That's the one. Towed along the predicted path, searching for tiny molten droplets, spherules, that would have cooled and solidified after the meteor exploded and fallen to the ocean floor.
And the source notes there was a Netflix film crew there documenting the whole thing.
Yes, apparently so. There's even a great personal anecdote shared from the expedition leader.
Oh, yeah? What was that?
The director of the film asked if he was running away from something or towards something, and the answer given was basically both.
Both.
I'm running away from some of my colleagues who have strong opinions without seeking evidence, and I'm running towards a higher intelligence in interstellar space.
Wow. That really captures the motivation, doesn't it? The pushback and the pull towards discovery.
It absolutely does. It frames the whole endeavor.
So after all that effort, towing this magnetic sled back and forth across the ocean floor a mile deep, what did they actually find down there? Did it work?
It did. They collected numerous magnetic particles from the ocean floor. They were described as these tiny metallic spheres, very distinct from the background of sand.
Metallic spheres. And were they analyzed? Did they figure out what they were?
Oh, yes. A team analyzed them, including Stein Jacobson, a renowned geochemist, and an intern named Sophie Bergstrom, who apparently got nicknamed the Spheral Hunter because she was so good at spotting these tiny things under the microscope.
The Spheral Hunter, I like it. So what did the analysis show?
It revealed something pretty significant. While most of the particles looked like, mundane industrial contamination, maybe coal ash or something, about 10% of them looked unusual, really unusual.
How unusual? What made them stand out?
Their chemical composition. It was dramatically different from typical solar system materials. Specifically, the abundances of certain elements they mentioned, beryllium, lanthanum, and uranium, known as belau, were up to a factor of 1,000 more than found in solar system materials.
Wait, 1,000 times more? That's not a small difference. It's huge.
No, it's orders of magnitude different. It's a very strong anomaly. This composition is highly unusual for known rocks from Earth, the Moon, Mars, or asteroids. It led them to conclude, quite strongly, that these specific particles were not from the Earth, not from the Moon, not from Mars, not from asteroids.
So the unavoidable question raised by this finding, as the source puts it, is, was this a rock from another star?
Just a really weird interstellar rock.
That's the natural origin possibility, yes.
Yeah.
Maybe from some exotic stellar environment we don't fully understand, like a planet getting shredded near a dense star or something.
But there's another possibility.
And this is the more provocative possibility raised in the material. Could they be of artificial origin? Technology.
Wow.
And the goal for future expeditions, they say, is to find bigger pieces of the object, because then perhaps you might even find, well, a gadget with buttons on it.
A gadget with buttons. The source includes a humorous aside about asking his class if they'd press the button right.
Yeah. Classic thought experiment. What would you do? Good question. Now, obviously, findings like this attract skepticism. Did the material address some of the immediate criticisms?
It did, yes. One major suggestion was that these spheres were simply coal ash, maybe from ships or power plants.
Okay, how is that ruled out?
By detailed analysis, they checked the abundance patterns of 55 elements from the periodic table and found they were completely different from the known signatures of coal ash. The Belau pattern just didn't match.
All right. What about the idea that maybe it wasn't a meteor at all? Could the data be wrong? Maybe it was just debris dropped from a truck or something mundane.
That's dismissed pretty firmly because the original detection, the fireball, the trajectory, all came from U.S. government satellites designed for exactly this kind of monitoring. And the search region itself was precisely mapped based on Department of Defense coordinates. They searched that specific area 26 times back and forth with the sled. The location and the original detection data point very strongly to a high-speed atmospheric entry event, not something terrestrial.
Okay, so they feel confident about the origin event and the anomalous nature of some particles. So where does the search go from here? What's next?
Well, the plan mentioned is for the next expedition, hopefully within the year, aiming specifically to search for bigger pieces of the object, maybe even the core.
Bigger pieces can tell you a lot more.
Exactly. Finding larger fragments could provide much more conclusive evidence about its origin, natural or artificial, and its detailed composition and structure.
And looking a bit further ahead, there's the Rubin Observatory coming online soon. That sounds like a game changer.
It really does. Scheduled to start major operations next year, according to the talks timeline, this massive telescope in Chile will repeatedly survey the entire southern sky very rapidly, covering it every 4 days with its enormous camera, 3.2 billion pixels.
Every 4 days. That's incredible coverage.
It is, and the expectation is that this will find more objects like ʻOumuamua, potentially many more. It will give us a much larger sample size of interstellar visitors to study, identify anomalies, and maybe find patterns.
More data points and potentially more weird ones. Okay, let's zoom out now to the bigger picture. The source describes the potential discovery of, well, proof of advanced extraterrestrial life or technology as nothing less than the next Copernican revolution. Why that comparison?
It explains why that goes beyond just the physical realization that we're not at the center of the universe, which, Copernicus and Galileo helped us understand centuries ago. This would be an intellectual shift.
How so?
Realizing that maybe you arrived to the play relatively late, cosmically speaking, and more profoundly that the play is not about us.
That really does demand a certain modesty, doesn't it?
Absolutely. The source stresses we should be modest, and it reinforces the need to actively search to find other actors that will tell us what the play is about, rather than just assuming our brief moment on the cosmic stage is the main event.
There's that common scientific saying you hear all the time, extraordinary claims require extraordinary evidence. How does the source respond to that, particularly in the context of searching for alien tech?
It counters, with a bit of noted humor in the source, that extraordinary evidence requires extraordinary funding.
Ah, the practical reality.
Exactly. Pointing to the massive investments we do make in other areas of fundamental science.
Like the examples given.
Right. Things like the $10 billion in the Large Hadron Collider to search for the Higgs boson particle, or the $10 billion in the Webb telescope to peer back towards the beginning of the universe. Gaining significant scientific knowledge, especially about something truly extraordinary and potentially paradigm-shifting, requires effort. Real resources. It doesn't just happen by chance or, on a shoestring budget.
Makes sense. The potential impact of finding definitive evidence, of finding we're not alone, is described as like finding a partner in the cosmos, something that would give a new meaning to our existence.
It would be a whole different ballgame, as the source puts it. It emphasizes that something from another star has nothing to do with us, meaning it won't just be a slightly different version of humanity, like in so much science fiction. It will likely be truly alien, truly different, and we better be ready for that.
It's not about looking in the mirror and just seeing a reflection of ourselves with maybe slightly different tech.
Precisely. It's about encountering the genuinely unknown.
And finding such evidence, maybe through more objects like ʻOumuamua or confirming the nature of those meteor spheres, the source suggests it might give us a sense of modesty. It could potentially bring back a kind of sense of awe, maybe like the awe Moses had looking at the burning bush.
But secular awe, perhaps.
Right, but based instead on something that was delivered from interstellar space from a neighbor, something tangible, scientifically verifiable.
And this kind of profound discovery, it's argued, could dramatically shift our priorities as a species. The source makes a stark contrast between the $4 trillion a year spent globally on military budgets, essentially killing each other for territories on this rock.
Yeah.
With the potential of realizing there is a smarter kid on the block, finding we're not the only or maybe not the most advanced intelligence around. This external example might provide a better role model than our politicians, is the provocative suggestion.
That is a provocative comparison, and the source follows that up with a really interesting thought experiment about that funding, right?
Yes. If that $4 trillion a year were redirected to space exploration instead of military spending, what could we achieve? The calculation presented is that we could theoretically send a CubeSat towards every star in the Milky Way galaxy within just a century.
Every star in the galaxy. With a small probe.
Within a century. A CubeSat, for listeners, is a type of miniaturized satellite, relatively small and inexpensive compared to traditional probes, but capable of carrying instruments. It shows the scale of what's possible if priorities shifted.
And what could we potentially gain from actually encountering a superhuman intelligence, as the source terms it? What are the possibilities mentioned?
Oh, they're vast. We might learn new physics, perhaps get answers to fundamental questions like what happened before the Big Bang. We might even encounter down the line something like quantum gravity engineers capable of creating a baby universe.
Creating universes. Wow.
Yeah. The source notes, again with that dry humor, that this job of creating a new universe can be perfected, and that perhaps learning about such things could help us, actually, especially given, as mentioned before, there's a lot of room for improvement right here.
A definite understatement there. So, okay, after laying out this entire case, the philosophy, the weird objects, the active search efforts, the potentially huge implications the source material describes, being asked a very direct question. Is it likely, truly likely, that within the next 10 years we will discover convincing evidence that persuades a critical mass of scientists, of colleagues, that there is indeed someone or something out there?
And the direct, unhesitating answer given in the material is simply yes.
It's just yes. Full prediction. This deep dive has really taken us on quite a journey, hasn't it? I mean, from the sheer scale of the cosmos and that fundamental question, are we alone, through a critique of our traditional listening methods, to these fascinating, maybe even unsettling properties of objects like ʻOumuamua and that 2014 interstellar meteor.
It really has.
Yeah.
And it's shown us the active steps being taken right now, like that incredible ocean expedition to recover actual physical evidence, all driven by, well, scientific curiosity and a willingness to consider possibilities that really challenge our current understanding. It highlights that this isn't just about finding aliens in some, simple sci-fi sense. It's about a potentially paradigm-shifting discovery that could give us profound knowledge and fundamentally alter our perspective on our place in the entire universe.
Yeah, absolutely. And it leaves you, the listener, with a really powerful thought to consider, one drawn straight from the source material we've been discussing. Look at the immense resources, the trillions of dollars humanity spends on conflict right here on our tiny rock. What incredible possibilities might open up if we instead united our efforts, pooling those resources to seek understanding, maybe even guidance from intelligence far beyond our own solar system? What kind of future could that enable for us? And maybe more personally, if you actually had the chance to ask a smarter kid on the block anything, what would you want to know?